So I did say I'm not going to put too many notes in here. Here I want this to mainly be about questions because there's stacks of notes and all is just blown out massively. So there's a few in there, but I would like you to supplement this to complement it with the notes book that we prepared for you that we went through in term 1. So we'll get straight into it, and and if you want, you can flip through your notes book. We'll have this open. You can flip through your textbook. We can talk about what we sort of did in each exercise. So in 2a, we're just doing operations with polynomials, right? So if we have some polynomial f of x and some polynomial g of x, we're going, what is 2f of x? What is 3f of x? What is f of x take g of x? Those kinds of pretty basic things with polynomials. In 2b, we look at zeros, roots, and factors. Okay, so that's where it crosses the x-axis. What are the values that make the polynomial equal to 0? And we've got 2 propositions there. Polynomial equality. So here's our first question. And we've got, if the left-hand side is equal, then we can expand and solve. So we won't go through this whole question, but I will just set it up for you to show you how we could go ahead and solve it. We've got some cubic polynomial, has 3 linear factors, 2 of them are identical, okay? So what that means, if 2 of them are identical, all right, it's going to be, I'm going to put it like this, we'll put it like this, ax plus b squared, okay? That's going to be one of the factors, right? Ax plus b squared, because it's an identical factor. And then we've got 3 factors, 2 are identical, so then this is just going to be some x plus c. All right, and if we expand that, we're going to get the cubic, 2x to the 3 plus 15x squared plus 24x plus k. And so your instructions are to find the roots and find the value of k. Now, for me, I'm looking at this, I'm thinking it makes sense for this value of a, I think, to belong in this one, and it makes sense for it to be 2. So even there, you can jump straight to this, okay? When we get 2x times x squared, that's going to give us the 2x to the power of 3. So this is one way that we can represent it. And all we would do is perfect square, expand this, and then you're just equating the coefficients. You develop some simultaneous equations, and you solve. So that's a skill that we learned in 11 methods in semester 1 last year. All right, we sort of recapped it a bit this year. Expand, equate the coefficients, solve. Excellent. So this is probably what I would really like to refresh next though, is the polynomial division. Okay, so I've got a number of questions there where we can start to work on the division algorithms. So in 2D1, we do the division algorithm for a linear. In 2D2, it's for a quadratic. And then in 2D3, we look at synthetic division. So we'll go through all of those. So the first one here we've got is 4x to the 3 take 6x squared plus 7 divided by x plus 3. So we set it up like this, right? We've got x plus 3 there. And then in the square, in the rectangle, we're putting 4x to the 3 take 6x squared. We need 0x, so we're going to have plus 0 lots of x. Okay, we need to have all of the degrees of x represented, and then we have plus 7. So this is what we're performing the divisibility of. We're going this polynomial divided by this linear factor. And then we go, what do we multiply x by to get 4x to the power of 3? And the answer is positive 4x squared. So we're going to put that above the x squared column. Okay, we get positive 4x squared. That's what we multiply to get 4x to the 3, and then we're going to do it. Right? We go 4x squared times x gives you 4x to the 3. 4x squared times positive 3 gives you positive 12x squared. Alright, so we've done that one times that one times that, and we've written it here. And then we subtract it away, don't we? We subtract 4x, that part cancels, and then we look here, we've got minus 6x squared, take positive 12x squared, gives us minus 18 lots of x squared. So our next question is, what do we multiply x by to get minus 18x squared? And that's where we're going to have minus 18. and like all of these components can flow down, right? I won't write anything. So we have minus 18 times x gives us minus 18x squared. We have minus 18 times 3 gives us
minus 18x.
It should be 18x.
Minus 18x at the top.
Ah, thank you. Yep, we need an x there, very good. Yep, yep. So then that's an x on it. Alright, and then we subtract that away. So we've got here 0 lots of x. So minus 18, take negative 18, that component is cancelling. It should always cancel because that's the one we multiply first. And then we have 0, take negative 54, we have plus 54x. Alright, so what do you multiply x by to get positive 54x? Plus 54. Okay, we'll multiply it to figure out our remainder. 54x and 54 times 3, 112. And so our remainder is 112, right? So let's look at the ways we can write this, and I did include that as a list. What's that? 160. Sorry, 54 times 3. So 162.
Slacking off, so
Yeah.
your viewers are going to leave you.
Is that all good?
So you did it on, like, then the 7 though. Where does the 7 go now?
Oh, yeah, sorry. There's a 7 here, isn't there? So now we have 7 take 162. Yeah, thank you. Alright, 7 take 162 minus 155. Thank you. There we go. Alright, so we've performed this process, but let's look at the ways we can represent it, right? So the question said, what's the polynomial 4x to the 3 take 6x squared plus 7 divided by x plus 3? And we've gone ahead and solved that, and we've got, this is the quotient, alright? So it's going to be equal, we've got the quotient, 4x squared take 18x plus 54, plus the remainder, which is minus 155, and the remainder exists on top of the factor that we're dividing. Okay? So here's one way we can check if we've got the right answer. Alright, we can graph this, and we see that they generate the same function. That's going to verify that we've done it properly. Alright, so yeah, that's a fun process. We've got a couple of those to get through. All good? Alright, so in the next one, we're dividing by a quadratic. So this is reflective of 2b equaling 2, and it follows pretty well the same process. There's just an extra term to consider. So we have x squared take 2x plus 5, alright, and we're dividing x to the 4 plus 2 lots of x to the 3 plus 4x plus 0x squared. Don't forget the x. Don't forget we need all of the degrees represented. 0x squared plus 4x and take 1. And so you can see we've got x to the 4, 3, 2, 1, 0. Everything's represented. And so we just ask ourselves, what do I multiply x squared by to get x to the 4? Because I want to get rid of that. And the answer is x squared. Okay? X squared times x squared will give you x to the 4. And we just multiply it through for all of these, right? And then subtract it away. So 2 take 1 is positive 4. So our next question, what do we multiply x squared by to get 4x to the 3 plus 4x? So 4x times x squared, 4x times minus 2x, 4x times 5. Okay, and then we've got 3x squared. What do we multiply x squared by here? 3x squared, positive 3. Follow it through, 3x squared, minus 6x, and positive 15. Subtract it away. Remember that number this time? 3 minus 16, take minus 6 and minus 16 plus 6, minus 10x, and minus 1 take 15, and then minus 3. So our quotient is this one. Our remainder is this one. And so when we divide by a linear, all right, we saw it here, we divide by our linear, our remainder is a number. When we divide by a quadratic, we see our remainder is a linear function, right? If you divide by a cubic, we're not required to. Your remainder will be a quadratic. Excellent. Okay, let's do the synthetic. Okay, so the synthetic division is a process for dividing a linear. All right, so it's just an alternative process that we explored, alternative algorithm. So we're asked to divide. I'll write up the problem first so you can see what we're component from. Divided by x plus 3. Okay, we're dividing by x plus 3. So remember what we do here is we set up all the numbers. And so along here we put the coefficients of our polynomial. So we have 2 lots of x to the 4. We have 0 lots of x to the 3. The 0 is still important. We've got minus 5, we've got 4, and we've got 2. And we're dividing it by x plus 3, and so we're going to put the number here as minus 3. Isn't it? So if we have x plus 3 as a function, the root 0 is minus 3. Okay, so let's show you how we do this algorithm. We always put a 0 here, and we go 2 plus 0 equals 2. And then we multiply this number by minus 3. 2 times minus 3, minus 6. 0 plus minus 6 is minus 6. And then we'll do minus 6 times minus 3, 18. I don't want to go too fast. We've got minus 5 plus 18. Is going to be positive 13. Positive 13 times minus 3, minus 31, plus 4, minus 35, times 3, 105, which takes us to 107. So then, our quotient, all right, we've divided a quartic by a linear, so we know this is going to be some cubic, and we've got 2x to the 3, take 6x plus 6x squared plus 13x, take 35, that's the quotient, q of x, and our remainder, 107 on top of, what are we dividing by? X plus 3. Okay, so that divided by that can be expressed in this manner. Okay, you draft that and see what they're saying. Verify that we've done it properly. Okay, so that was division. Hopefully we're sort of remembering that a little bit. Excellent, let's proceed. So then we went on to look at the remainder theorem. And so we've got, when a polynomial p of x is divided by x take k and it has a remainder r, then p of k equals r. So that's the rule we're going to apply in this question. Find a, given this polynomial, when it's divided by x take 1, the remainder is 4. Okay, what this means is p of 1 equals 4. Alright, p of 1 equals 4. And so when we consider the polynomial is x squared plus ax take 5. And so if we're finding p of 1, we're going to have 4 equals 1 plus a take 5. We get a is 8. Alright, so that's remainder theorem. Then we've got factor theorem. For any polynomial p of x, k is a 0 if and only if x take k is a factor of p of x. So what that means, okay, is p of k is, if k is a 0 or a factor, then p of k equals 0. Alright, that's what the factor theorem is saying. So we can find a given x take 1 is a factor. Alright, so what that means in our circumstance, p of 1 is 0. Okay, we're just going to repeat that there, but instead of the number here, we've got a 0. So find a given, here's our polynomial. 1 take 7 plus a take 9 is equal to 0. So we'll collect these, what do we get? Minus 6 take 9 minus 15 is 0. Okay, in 2G, we have a cubic polynomial. 2 take I is one of the roots, all right, one of the factors. So what does that mean? The other one has to be 2 plus I, right? So if we have 2 take I and 2 plus I, right, the other root has to be symmetrical for it. And so then this is where we go, what's the quadratic factor? Well, the sum of these roots, if you add those roots together, you're going to get positive 4. The product of these roots, right, if you multiply them, I might perform the multiplication just to do a bit of a refresh of that. Here we have a difference of 2 squares, right? A take b times a plus b. So you can FOIL it if you want, but it's going to be a squared take b squared. Right? What is I? I is the square root of minus 1. So we have take away the square root of minus 1 squared. And the squared and the square root will cancel. So we have 4 take minus 1, we have 5. The product of these roots is 5. And so then the quadratic factor is going to be a times x squared. Take the sum times x plus the product. Alright, that's what it is. X squared, take the sum times x plus the product. So in our circumstance, x squared take 4x plus 5 is the quadratic factor with those roots. Alright, so that pretty well brings us close to the end of chapter 2. In 2I1, 2I2, we're looking at graphs. Right, we did that ad infinitum in year 11. Finding the equation from a graph, finding graphing from an equation, and so forth. So you can have a look there. In 2J, we've got polynomial equations, so finding roots and talking specifically about using technology. And then we move on to chapter 3. All right, so chapter 2, polynomials. Chapter 3 is about functions. Functions, relations, we have the different types of functions. All right, so firstly, we're just looking at composite functions. And so we've got the function f of x equals square root of x and g of x. Can someone tell me what you guys have for g of x?
5 take 2x.
Excellent. I didn't remember to change it. 5 take 2x. Very good. Now we're told find f of g of x. So just on notation, right, I just want to talk about notation. This is how I'm going to write it, and this is how I've seen Stace write it in the past. Alternative, if you're doing the MASA exams as well, like they tend to use the alternative notation, they do something like this, f dot g dot x or something like that. It means the same thing, okay? Whichever one comes first, you're putting the other one inside of it. Okay, so we're finding f of g of x, so we're putting g of x inside f of x, right? So we're going to have f of g of x is equal to the square root of 5 take 2x. Right, that's the composite function. But then the next part, state its domain and range. So we can hop on our calculator and sort of get it from the graph, right? But let's make an argument, okay? For this to exist, we're only going to consider this being positive. We can't perform the square root of a negative number when we're graphing it. So therefore, 5 take 2x has to be larger than or equal to 0. Right? The inside here can't be negative, so therefore it has to be larger than or equal to 0. So this is an argument for domain, right? And so this is an inequality that we're going to solve. First, we'll subtract 5 from both sides. Don't jump any steps when you're doing an inequality because there's a little rule you need to consider, right? So let's subtract 5 from both sides. So we're going to have minus 2x is greater than or equal to minus 5. And then we're going to divide both sides by negative 2. Now, whenever you multiply or divide by a negative number, it flips the inequality. But that's the only time. So we divide both sides by negative 2. It's going to reverse the inequality. And over here we get 5 over 2. All right, and we should be able to see that from the graph if you look at the graph of it. And as for the range, okay, so that's the domain, it's a statement from domain. For the range, it's going to be larger than or equal to 0 because we don't get negative values. When we're graphing the function. Excellent, so that's 3a. 3b, we've got the inverse function. All right, so this is a good one. We can get it from the graph. Okay, we use our calculator to support us. But let's do it manually first. So I've just provided a rough sketch of it, and that's all we're going to do, just to demonstrate and sort of recap what it is. So we have the function y equals 3x plus 2. So firstly it says sketch its inverse, and then find the inverse using variable interchange. So if we have 3x plus 2, right, we're thinking we have a y-intercept of 2 and a slope of 3. That means we go across 1 up 2, across 1 up 3, across 1 up 3. So it's got quite a steep slope. So it's going to look something like that. Right. Now, for the inverse function, it has to be the mirror image about the line y equals x. It's the mirror image about the line y equals x. So what that means, y-intercept becomes x-intercept, okay? Wherever it crosses the line y equals x, the inverse would also cross at that point. And so rather than going across 1 and up 3, it's going to go across 3 and up 1, across 3, up 1. So you know, it's going to look something like this, right? That's the inverse function. Okay, so from that you could graph it and you can know what the graph looks like, and you could use coordinates along that line to find the inverse function. You can think about it. We're going to use variable interchange. So if we have y equals 3x plus 2, then using variable interchange, we're just going to swap the x and y here, right? We're going to have x equals 3y plus 2, and we're solving for y. We want it expressed as a function of y. So we'll have x take 2 equals 3y, and we'll have y equals a third x take 2. All right, so that's what this graph is. So that's the inverse function. Make sure you're comfortable with how you can find it on your calculator. In 3C, that's a very short exercise. We looked at reciprocal functions. And then in 3D, reciprocal of other functions. So I've got an example of that one. It says, find the reciprocal function and state its domain and range. So if we were to graph this function, right, we've got, what is it? It's going to be 1 on top of f of x. So here that's going to be 1 on top of x take 1 times x take 2. Now as far as the domain goes, it's not going to exist when the denominator is 0, right? So the domain is pretty well any value except positive 1 and, have I written that right? X take 1 x plus 2. Positive 1 and negative 2. Alright, so the domain is going to be any other value except those two numbers that exist everywhere except there. And then for the range, like we can try and make a mathematical argument, but the simplest way is going to just be to look at the graph. Alright, to look at the graph. And I think it's just y does not equal 0 because it's asymptotic to the x-axis. So you check your graph. Okay, and then sketch a graph. You guys know how to sketch graphs. All right, so when there is a graphing question in the exam, 3 marks, make sure you get it. Don't want to lose marks on a graph. So. All right, 3E, we have rational functions. Okay, so maybe just a really quick recap of what those are. That's when we have f of x on top of g of x. All right, f of x on top of g of x. And so what's that? That's going to be asymptotes when g of x is 0, undefined at those points. Roots occur when f of x is 0, when the numerator is 0, so that's rational functions. And then we get into absolute value functions. So the first one we've got is define algebraically. So maybe I'll just provide a quick recap of modulus algebraically. So the modulus of x is going to be x for x is greater than or equal to 0, and minus x for x is less than 0. That's how we define it algebraically. So let's look at our circumstance. We have defined algebraically and graph the modulus of x plus 2. Okay, so I'm going to define it, right, and then I'll graph it and I'll make a link between it. So the modulus of x plus 2, right, it's going to be x plus 2 for x plus 2 greater than 0. Alright, and so what does this inequality solve to? X is greater than minus 2. Alright, so it's going to be this function over that domain, and it's going to be negative x plus 2 for x plus 2 is less than 0, x is less than minus 2. Okay, so we've defined it for those domains. Alright, let's graph it. So, equation of a line has a slope of 1, y-intercept of 2, x-intercept of minus 2, so minus 2, and there's the point where it changes, right? So you can think about it two ways, okay? The first is, the graph is really simple to do because it's just positive, okay? It has to be positive there, and then it has to be positive here, because it's the modulus of the whole thing, it can't go below the x-axis. Alright, and then of course the other way to think of it is, well, it's going to be the equation of that line, okay, y-intercept 2 over that period, over there, alright, so that's going to be that line. And then for this period, for x being less than minus 2, it's going to be this line. Well, what is that? That's minus x, take 2. So this one has a y-intercept of minus 2. Not that it's going to exist at that point, it can't, but that can be indicative of, that's the line that's going to exist for values of x less than minus 2. Alright, so we can graph it there, we can graph it on our calculator, either's fine. Okay, in question 11, I won't go through question 11 right now, just because we're ticking out of time, but we can use our calculator to do that, right? We've got quadratic, and we've also got the rules for how those function works, okay? So if you have a look in your notebook, it's very clear. I think I copied it straight from the textbook, what the modulus of f of x does and what f of the modulus of f of x does. So you can have a go at them, use your calculator to support you. All right, solve for x. We've got the modulus of 2x take 5 equals 10. Alright, so this is quite good because we've been doing this a bit with the logistic functions recently with ln, and so we know if we want to get rid of this modulus, what we do is we put a plus or minus here, right? So we're going to have 2x take 5 equals plus or minus 10. We need to consider both. And so then you're just solving two linear equations. You consider the positive case, and you consider the negative case. So what do we get? 2x is 15, x is 7.5, or 2x is minus 5, x is minus 5. Plus 5. Excellent. So there's a bit of a summary of polynomials. So yeah, it's up to you where you direct your efforts. You've got textbook, we've got revision guide. I've got one hard copy of the revision guide. I might go grab that now. We'll have a bit of a squiz at it. But yeah, let's do some revision on this unit.